ITTS Geophysica Closed Joint Stock Company and ERGIS Scientific Production Enterprise present the PS112/18/400 drill. Secondary formation exposing is one of the most important tasks solved during well completion. Primary function of any perforation is to ensure dependable hydrodynamic connection in the well reservoir system. At present, there are three main techniques of secondary exposing of producing formations in cased wells: shooting, hydraulic jet perforating, and mechanical method, which includes drilling. Most common are shooting and hydraulic jet perforation. However, these techniques may result in breakdown of the casing string and the cement stone not only within the perforated zone, but also in the areas of girth with separate producing formation from aquifers. Such exposing results in accelerated drawing of the well. Besides, the channel formed are rather shallow and intercommunication between the formation and the well is incomplete. Such exposing does not permit to correct errors made during primary exposing and cementing. They are even aggravated. The stated disadvantage determined the activity in search for non-impact techniques of perforation and devices suitable for such purposes. Drilling is classified as a sparing technique. Unlike shooting and hydraulic jet perforation, it affects neither the support integrity nor the lithological properties of the producing reservoir rocks. Drilling with deep penetration of perforations is efficient in wells of any destination operating producing formations of various type and lithology. However, unlike other types of perforation, the greatest effects occurs when exposing of producing formation with bottom water objects where the oil-saturated portion of the reservoir is separated from the water-saturated portion by a thin, unstable girth, or when exposing permeable interlayers of thin layer formations selectively. A good effect is expected if drilling is used as an intensification method during additional perforation of heavily mudded reservoirs which have been operated for a long time. Efficient hydrodynamic connection in the well reservoir system. Minimum skin factor. Selective spot perforation of complex structured formations. The well bore support remains unbroken. Thin argillaceous girth remain unbroken. The natural formation structure is not disturbed. In order to solve these tasks, the Permsky Инженерно-технический Center Geophysica Closed Joint Stock Company, together with the ERGIS Scientific Production Enterprise, have developed and put in production the cable tub PS112/18/400 drill, which the jack bit outputs of 400 mm and the perforation diameter of 18 mm. The perforator is designed for execution of works in wells of various destination, cased by flow strings of 146 to 168 mm diameter. The perforator allows to produce deep penetration perforations through which the well bore intercommunicates with the unbroken formation area, which has natural filtration characteristics, without breaking the well bore support and impairing natural drainage properties of the producing reservoir. The deep penetration drilling techniques allows to minimize the skin factor, spot perforate, the thin layered formations and formations located near water bearing once selectively. Advantages of the deep penetration drilling technique allow to achieve optimal operation of productive reservoirs. The perforator comprises a number of electromechanical and hydraulic system and assemblies which ensure fixation of the perforator in the well, drilling of deep perforations in the well bore wall and the productive reservoir, and subsequent return of the perforator mechanisms to the run-in initial position. The perforator comprises the drive module, which imparts axial advantage to the flexible shaft bearing the cutting tool. The clamping module, which fixes the perforator in the well. The flexible standoff assembly, which changes the flexible shaft from axial direction to radial direction. The flexible shaft bearing the cutting tools on its ends. The wash-over system, which is used for washing chips and sludge out of the perforation during drilling. The mechanism used for resetting the flexible shaft with the cutting tool. The control panel is used for controlling the device from the well surface and monitoring the drilling process. Drilling by means of PS 112-18-400 shall be performed by a standard geophysical crew equipped with a well logging truck hoist with a 3-core cable of up to 5,000 meters. Before lowering the device into the well, its functionality shall be checked on the access board. Then the device is lowered into the intended perforation zone using the lodging cable. The clamping modules fixes the device in the well bore, and the drive module produces axial thrust and transmits the rotation force to the flexible shaft with a cutting tool on its end. The flexible shaft changes axial motion of the flexible shaft to radial motion. Coming out of the device case, the cutting tool drills the wellbore walls, the cement stone and the rock, producing a perforation of 18 mm diameter and 400 mm length. Then the resetting assembly resets the cutting tool. The clamping assembly returns to its run-in position. The device moves over the next drilling point. Good workability. Process fail safety. Expensive high-power pumping equipment is not required. Environment friendliness and safety of the technique. Maximum waterless operating conditions. Efficient stimulation technique. Minimum financial costs. PS 112-18-400 specifications. The perforator equipment is operated using a 3-core lodging cable of up to 5,000 meters together with a well lodging system and oil and gas type well logging truck host. Maximum well temperature 100 degrees Celsius. Maximum pressure 35 megapascal. Perforation diameter 18 millimeters. Perforation depth 400 millimeters. Drilling time per perforation 30 minutes maximum. Perforations per trip 5 minimum. Power supply from AC mains of 50 Hz and 380 plus minus 38 volts. Power consumption 2 kilowatts maximum. Overall dimensions of main constituents of the PS 112-18-400 equipment. Borehole perforator. Length 4.5 meters maximum. Outer diameter 112 millimeters. Control equipment. Control panel 177, 340, 436 millimeters maximum. Power transformer 186 to 436 to 454 millimeters maximum. Weight of main constituents of the PS 112-18-400 equipment. Borehole perforator 100 kilograms maximum. Ground-based control panel 20 kilograms maximum. Power transformer 35 kilogram maximum. A PS 112-18-400 new generation deep penetration drill opens us promising capacities for secondary exposing of complex structured productive reservoirs of various lithology. No repression on the productive reservoir. No temperature impact. No breaking loads. The flow strings and the cement stone remains unbroken. The reservoir preserves its natural structure. The perforation wall drainage area is increased. Minimum skin factor. Optimum operating conditions of productive reservoirs. Should you have any questions or wish to order the PS112-18400 drill, contact the Permский инженерно-технический центр Geofizika Closed Joint Stock Company, Perm, Komsomolsky Prospect 34, Office 601, phone, prefix 342, number 219-6301, 219-6302, email pitc@permonline.ru.